Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the minimum genetic mutation problem. This is my second go at recording the intro to this because my computer completely corrupted the video. We've got the second half of where I actually solved the problem was recorded fine, so this is just me redoing the problem description. A gene string can be represented by an 8-character long string with choices from A, C, G, and T. Suppose we need to investigate a mutation from gene string start to a gene string end, where one mutation is defined as one single character changed in the gene string. For example, AACCGGTT goes to AACCGGTA. T became an A. There is also a gene bank that records all the valid gene mutations. A gene must be in bank to make it a valid gene string. So if we don't know that we can turn the A into a G, then we can't assume we can. Given the two gene strings start and end and the gene bank, return the minimum number of mutations needed to mutate from start to end. If there is no such mutation, return -1. Note that the starting point is assumed to be valid, so it might not be included in the bank. Right, I will hand back to past Aaron to actually go and solve the problem. And let's get to it. So start is AACCGGTT, end is AACCGGTA, and the bank includes just the end. Output 1. Start AACCGGTT and AAACGGTA, bank those things again. So we can see here, first it can step to this one, and then it can step to this one. We don't need this one at all, I don't think. And then the same again. So my immediate thought with this is it's a graph search problem in disguise. It's actually a relatively straightforward graph search problem in disguise. This seems like a breadth first search, where the edges are defined by, well, no, let me say that again. The neighbors are defined by the bank and an edit distance of 1. So this here, its neighbors are everything in the bank that is 1 edit away from it. And we can basically just do that infinitely. We can do that for everything in the bank as well. So this has some neighbors, and everything in here has some neighbors in here as well. And yeah, and then what we can do is we can just do a standard breadth first search through it. So let's do self.neighbors is make neighbors bank start. Oops. And then what we want is we want a queue is import collections. Queue is collections.deck. And we want it to start with start while queue. Spell queue. I'm going to need scene is a set. Car is queue dot pop left. If car equals end. I need a slightly different thing here. I don't want it to just be start, I want it to be start 0, because here I want it to be current, and steps, return steps. If car in scene, continue. So if we've already seen this thing, then stop. For net, for n in I don't need to call this self.neighbors, just neighbors is fine. If you haven't noticed from my coding style, I don't tend to use object orientation that much. I'm a functional programmer through and through. Q.append, I want to give it n steps plus 1. This, and return -1 if we get all the way through and we have not been able to return the number of steps. So this is your absolute bog standard breadth first search through a graph. You have a queue, you have a set of things you've seen. While you can take things off the queue, take something off the queue. If it's where you want to be, you're done. If it's not where you want to be, but you've seen it before, stop, because you've already found the shortest path to that in the past. Otherwise, go every direction you can and loop, basically, loop around. So, the only tricky bit here is we need to do this make neighbors business. Neighbors is going to be a dictionary that has each thing in the bank and the start is a key, and the values are all the values in the bank that are one edit away. So for how do I want to do this? Let's not worry about doing it too efficiently. For source in start plus bank, for end in bank, if edit distance start source target. So I tend to use certain symmetries. Start goes to end, source goes to target, that kind of thing. If the edit distance is 1, actually let's do a collection.default dict with a set neigh neighbors dot add neighbors source dot add target. By symmetry, yeah. I'm thinking here, by symmetry, we immediately know that if source and target are next to each other, target and source are next to one another. So that means I don't actually need to traverse everything in the bank for the target. I just traverse everything in the bank that's after where I currently am in the bank. So what I'm going to do is I'm going to enumerate bank. I'm going to make it a list, which is a little bit wasteful, but it is what it is. Start at -1 for I, source for target in bank starting at I plus 1, I guess. And then neighbors target dot add source. Return neighbors. So this is a little bit cheeky, but so what I want to do is I go through the bank enumerated plus the start thing, and then I say, well, for everything after that in the bank, so if it's the start, that's everything in the bank. If it's something in the bank, it's everything after that in the bank. What I want to do is I want to work out the edit distance, source and target, and then add the symmetric directions. So that just now leaves us with edit distance self source target. I think I can just do sum a equals b for a b in zip source target. I think that'll work. Possibly. This may not be valid, Python. Yes, I did. For some reason, that class is a lowercase name. Did you mean pop left? Yes, I did. Clearly, I've not used this library in a while. Wrong input. Output expected. Okay, show me neighbors. I'm immediately suspicious. It's empty. Yeah. Oh, that's the wrong way around. There we go. So AACCGGTT, yep, that's one away. AACCGGTT, CGTA, yep. So that's working correctly now. I was immediately suspicious about neighbors, and sure enough, it's this one here. I was counting where they are equal, but that's not the edit distance. I want where they are not equal. That is what an edit distance is. Let's use all the example test cases. And it looks like it's working pretty well. The one problem might be if it's too inefficient. Not quite sure how it would be too inefficient, but I mean, I know memory-wise we're being fairly wasteful. Lots of duplication going on. These strings are being copied all over the place. But in terms of speed, it shouldn't be too bad. Let's click submit and see what happens. Ooh, this doesn't bode well. No, we are too slow. We are too slow. Time limit exceeded. Why? Oh, God, you're not even a big... Oh, geez. Okay. Why are you bad? Oh. So, my standard breadth search has a bug in it. See if you can guess what it is. Ready, ready, ready. I don't add anything to scene. Scene.add current. Right, that should work quite a bit better. Oh dear, there's always one thing, isn't there? God. You maintain the scene set. Yeah, exactly. You maintain a scene set and you never actually use the scene set. I swear one day I will write a graph search right the first time. It's not going to be today at all. Not at all. Right. That's it from me today. When I upload this video, I'm going to be trying to do a couple of things differently tech-wise. So do let me know. Hopefully the quality will be... I'm going to try slightly lower frame rate, but hopefully that'll mean you'll get a slightly higher resolution earlier on rather than YouTube taking 10,000 years to process the 4K version. But anyway, that's it from me. Do remember to like, comment, subscribe, all that good stuff, particularly giving a bit of feedback on how the appearance of this video is. And I will see you next time. Bye.